More about resistance. In this video we're going to look at combinations of resistors in parallel and in series and combinations of parallel and series so that you can work out different resistor values when asked questions in your exams. Before we begin, we need to look at the different equations used when working out total resistance, because there are two. There's one used for resistors in series and one used for resistors in parallel. If we have resistors in series, we just add them together to get the total resistance. Whereas if they're in parallel, we must use the equation 1 over RT, which is the total resistance, is equal to 1 over R1 plus 1 over R2, and so on. Let's start with a series example. So, there we have our series circuit, and let's identify which equation we need to use. Well, for series, we use RT is equal to R1 plus R2 plus any other resistors. However, in this equation, we only have R1 and R2 because we only have the two resistors. Let's give some values. Well, let's use a 20 kilo ohm resistor and a 33 kilo ohm resistor, substitute their values in, and we find that RT is equal to 53 kilo ohms. So that means we could take both of those resistors out of the circuit, replace them with one 53 kilo ohm resistor, and we'd have the same current flowing around our circuit. Likewise, let's now look at a parallel example. There we have a parallel circuit. It's worth noting that in this circuit, both resistors have the same potential difference across them. However, they can both have a different current flowing through them. Let's identify the equation. 1 over RT is equal to 1 over R1 plus 1 over R2. We've been given some resistor values, which were the same as in the previous equation. And what we're now going to do is substitute those in, and we're going to see that we will get a different resistance compared with the previous circuit. So 1 over RT is equal to 1 over 40 times 10 to the 3 plus 1 over 20 times 10 to the 3. That gives us 1 over RT, the total, is equal to 75 times 10 to the minus 6. However, we don't want 1 over RT, we want RT. So we must do the reciprocal of this, giving us 1 over 75 times 10 to the minus 6. If we put this in a calculator, we get the total resistance is equal to 13.3 kilo ohms. Now let's look at a combination. In this circuit, we have 4 resistors. It does take practice to identify how we're going to calculate the resistance of the entire circuit, because you can come up with different combinations. However, this is a common combination. We have 2 branches, both with 2 resistors in. So firstly, we need to identify the total resistance of the 2 resistors that are in series with each other. And we're going to come up with 2 different values, one for R1 and R2, and another for the branch with R3 and R4. I've drawn a circle around the 2 different branches, and I've substituted in some values and worked out the answers, although they're not written down there. Feel free to check the answers yourselves. But we're not finished yet. We must now work out the total resistance using our parallel equation, because we can imagine that R1 and R2 have become a single resistor with resistance 40 kilo ohms, and R3 and R4 have also become a single resistor with a total resistance of 45 kilo ohms. So we substitute those values into our equation, and we see that the total resistance comes out to be 21.1 times 10 to the 3 ohms.